Hi everyone, or good morning. Not that many people here though, but I'm happy that you actually made it. It's awesome. For some cloud shenanigans. This will be a little bit brief. There is like 100 slides. We are not going to look at all of them, so we're going to jump a little bit. But let's get started. I need to time myself because I'm very good at talking a lot of nonsense. So, okay. Let's do this. My name is Jesper, and I work as a freelance penetration tester. I focus mainly on offensive security. I break things and then I leave. That's what I do. And I write a report on how I potentially broke that thing that I watched, basically, or how I attempted to break the thing. Yeah, I do a little bit of everything. So I have a security conference, not a developer conference in Gothenburg called Security Fest, where everyone should attend. Even, yeah, all of you. And then I run something called Säkerhetspodcasten with like former colleagues, which is Swedish security podcast, basically banter of security-related stuff. And I was fortunate enough to be one of the really shady guys on the on your right, I guess, or your left, in the Swedish TV series called Hackad. How many here have seen it? That's good. Good. And if you haven't, go watch it. So we can do a season 2, which would likely not happen. Before we start this presentation, so everything that I will talk about today is something that I found in the field of my work, basically. But in order not to get sued or be able to have a job tomorrow, everything is sort of blurred down and it's out of context. Usernames and hosts will sort of jump back and forth, and that is exactly how it was intended to be. So yeah, that's basically it. But since it's early morning, we need to sort of prime ourselves, right? Everyone feels a little bit like tired. Maybe you had a beer or two yesterday, or you slept bad, or whatever. But now it's time to get in the mode. So we're going to embark on a big adventure. The adventure will be about the web application horse, because obviously, right? And it will be about this one. I'm going to use the clicker because I have one. It will be the Kubernetes Fortress of Doom, of course, because why not? And it will be the SaaS authentication provider in the cloud. So we're going to try to combine these things in order to go on a treasure hunt, basically. So the idea is I have a laser here, which is freaking awesome. So I'm going to do it on the left. So this is us, the pirate here. We're going to try to use the mighty web application horse to get inside of the Kubernetes cluster, get into the workload village, using something in the SaaS mountains, in order to find a ticket here, to cross the sea of unbreached clusters, into the end here, where the dragon and all the treasures in the cloud sort of lies, right? Sounds good? Perfect. So this is basically the adventure we're going to do, and we're going to do it with a practical example. How many here, like everyone here is the developers, right? So raise your hand. This is good. Stay up. How many here know Kubernetes? This is good. Good. Cloud? Good. This will work out perfectly. Okay, so the gist of the whole thing is that we have an application that lives in a Kubernetes cluster, right? It is a pod, it's a container, it's an image. It lives inside of the Kubernetes cluster. So far, so good. That cluster has an ingress or some kind of traffic boss that sort of says that if you're going to go here, you have to cross my ingress, and then I'll give you to the right namespace, and I will lend you a place inside of my cluster. Here's where my sort of workload lives. Here is the web application thing. That web application needs to talk to something else. In this case, it needs to talk to an authentication provider, and this authentication provider lives in the cloud. This is a pretty cool thing. I had to obfuscate it a bit. This is a SaaS authentication provider that is built in order to help you sign in to your bank. So a lot of banks use this. No Swedish ones, so you're safe. So in general, there's like everything OAuth, everything SAML, everything aggregated identity, everything that has to sort of correlate with authentication. They sort of handle, because that's hard, right? Authentication is hard. Even if you do it right, it's hard. So what they do is they build sort of a UI where you sort of log in as an administrator and you can add like federated authentication, single sign-on with Okta or like a cool metric, a cool YubiKey or WebAuthn and authentication endpoint like SAML or whatever, right? You get the gist of it. But in order to sort of make it your own, you have a web UI where you can add CSS, you can add forms, you can add a bunch of shenanigans which are nice. And we're going to try to find a vulnerability in that one, which after a period of digging, of course, like the nice golden here, the web application has to take user input, and that user input has to be validated. And the web application uses expression language. Anyone here hasn't heard about it or has heard about it? One, that's sad. It's basically an extension that makes you, write the sort of output back to the backend. Basically, you can manipulate it. So it doesn't really matter. But then again, like it's user controlled. That's what you need to know. Like the user, in this case, the administrator of the bank, creates an authentication flow manipulating these entries that are user controllable but will be executed in the backend. So you guys and ladies and the gender neutrals, no code. Can you see something funny here? You can say yes, I won't hold you to it. This is the bug. No? This is what I do. It's pretty boring. So this is what I do. So in this case, we have a problem. So anyone figured it out? Yeah. This guy? Yeah, so why is that broken? Could be. Now in this case, I can control the URLs. I can, like, is there anything that sort of validates what I'm putting in here? That's the question. And now I know more than you, so I know that this is executed in the back end. So I'm not going to do this. I don't have time for this. So let's go. Now, can you find something cool? So you didn't see this. None of you see this. So this is like the thing with penetration testing. I only do code-assisted penetration testing. I don't do any black box testing whatsoever because it's too expensive. So people pay me to find as many vulnerabilities as possible, and that is done through code access or repo access or some kind of read access to repositories, cloud infrastructure, what have you. So in this case, we have the source code, and we know that the authentication provider will, the request will go through an EL object, and that will be validated at the backend through a function that we can read, basically. And that said function runs in a Python binary, basically. So when it's concatenated, when it's sort of consumed by the backend, a Python binary will sort of digest this and do something. And then we're able to sort of extend the request by breaking it using pipe. Make sense? And everyone knows what pipe is. So we do something and we send it out to something else. And this is awesome because in this function is like, send everything here, validate the password, and if the password matches the sort of checksum basically stamped by the authentication provider, then woohoo, you're in. And then you can sort of extend it. You can sort of do stuff like this, which gives me the possibility to inject something. So this will be, you can take the IP, it's down. It's a DigitalOcean host. But this is a one-liner reverse shell. So when I execute this, it will do all the shenanigans it needs. It will use the pvget function, getPass, but it will also pipe it and then spawn a shell from that machine that connects out to my machine. And guess what? That is, of course, running Alpine as root. Anyone here feels that they've done this? Or are you using multi-boots? This guy? It's awesome. It's actually, it's not an embarrassing thing to admit because everyone does it. except if you had me there, you started, if you had me there for like 4 years, like a Swedish bank, they have implemented distroless containers. They have MTLS, they have different clusters, they have like role bindings to deploy. So it's like, it's not nice to be a pen tester there. It's terrible. Because you can't find it. It's like you're writing a report about nothing. Like semantics, like, you should do this, maybe, perhaps. They're really good. But the norm is basically this. So you're running as root, and no one seems to care because it is a pod, and it's a container, it's a self-sufficed ecosystem. Or is it? That's where I come in. So now we sort of have a shell inside of a workload inside of a cluster. Now what? We need to recap, right? So what we did was that we found this injection vector that we sort of jumped very quickly in order to get to the nice things. That made us, the pirate was able to sort of use that ability and jump in here. So we're here now, right? Everyone agrees that we're inside someone's cluster. But we're in like a namespace, a public namespace where a web application lives. We're root, which is awesome, but it's not really fun, is it? So far, okay, and our remote code execution in the front end is bad, but it's not really the critical that we want. We want like the maximum impact, and we want the awe factor of the ones that are going to read our report. So we need to pivot, right? And that's where post-exploitation comes into the picture. And this is a treasure trove of fun, because anyone here knows exactly how Kubernetes works? Yeah, the guys who sort of did this, which is the correct answer, because no one does. And when you run it in the cloud, there is so many flavors. Like there's like this ice cream thing. It's like gazillion flavors. No one really knows what's going on. And I'm going to give you some things that you should not do in order to make my job a lot harder, which is sad, but that's what we're going to share today, basically. So, tools. Everyone needs tools. So I'm going to give you the most awesome hacker tools in the world. And it's curl. Curl is the best hacker tool ever, right? So let's say you're in a pod. The first thing you want to do is sort of do reconnaissance. Where am I? What am I doing? What is here? Where am I in the world? So the first thing I tend to do is download the kube control CLI, basically. And you can do that because egress filtering is hard, so we don't do that. So my pod can, of course, reach the internet because of reasons, because that's something that we need. Having a full shell, having Alpine with curl and vget and make and all the nice toys for a penetration tester, it's awesome because I don't have to install anything. I could just download the utility. And since we have the default service token auto-mounted by default, I'm able to query the cluster. Then again, if I'm in AWS, Azure, or a GCP environment, I can download the shells as well, right? And then potentially I could use those CLIs in order to get an additional foothold and pivot out. But now you think, yeah, well, you have like a shell, your root, but you have nothing to do with the control plane in the cluster, in the cloud, right? So we can reach the cluster's control plane, but we're not really able to reach the cloud, right? Now you're going to say yes, right? Perfect. So the default service token that I talked about, it is like the default service account, basically. It's not really privileged, hopefully. If you appended some kind of access to the default service token, leave and fix it and come back, because that's really bad. That is there by default and should not be there. It's not really necessary. If you haven't done something really weird, you should have specific service accounts for the services that you spawn up, basically. You should not rely on this, because this is there by default if you don't disable it. So this could be the case. This is a one-liner that you could use in order to see what your default service token can do. If this is the case, you failed. Game over, go home, do something else. Here, the default service token is able to get all the secrets in the administrative namespace and do a bunch of shenanigans, basically. Now it's over. Now it's completely over and done. This happens. It's not really as common as it was in the before time, but this actually still happens. So don't append any access rights to your default service tokens. That's a really, really, really bad idea. So yeah, if we find this, then it won't be a hard problem for us to sort of extract everything in the cluster, and then we eventually will sort of have the enough access rights to do whatever, basically. Configuration maps, anyone use them? Good, because you sort of have to, right? And you use Helm as well, or something, maybe? Helm, yeah, of course. So the problem with this is that this is not a container for secrets whatsoever. It's a container for configuration. But guess what? If you put something in the config map, which no one here obviously have never done, it is always readable by anyone, by default, because it is a configuration map. So it is like, if you put secrets there, and I have a low-level access to the cluster through the pod that I just owned, I can read the configuration. I don't need a service token, I don't need any credentials, I need nothing. I can always read the configuration maps. So if you put secrets there, bad thing. So don't put secrets in configuration maps, because then things go bad. Could be like this. So we install the kube control, and then we say get configuration maps from all namespaces and give me it as a YAML, and woohoo! Now we're able to get AWS access, and we're able to reach the Elasticsearch instance, and yeah, even send email in this case, which is awesome, right? So don't do this either. Okay, now the fun thing starts. So the cluster control plane, basically it's a way to scale up, scale down, manage resources and whatnot. Yeah. So there is like 2 control planes, if that makes sense. So the cluster has its own in order to provision and scale. And the cloud provider has its own in order to provision and scale. And there is glue between them. And now we're going to do shenanigans with those. So we're going to talk about something called node impersonation. Anyone here, a node? What's a node in Kubernetes? A node in Kubernetes is basically, yeah, good that you raised your hand. That was a really rhetorical question. Like, should you answer me? That no one will hear you, that's just retarded. But it's morning, I'm sorry. So, okay, so a node in a Kubernetes cluster is sort of the thing that makes it tick. So inside, your pod lives inside of a node, and the node is sort of consists of a cluster. There's a master node that sort of decides what's going on. And imagine if we could do node impersonations, that would be awesome, right? So one thing that I'm playing a lot with right nowadays is bootstrap. So make something automatically go ba-bam, scale, and just automate, just magically work and become more of nothing. Bootstrap is a cool thing. And in Google, in this case, you bootstrap it through the metadata layer. It's actually a universal thing. It's actually the same on all of the cluster. It's a little bit different flavor. So the bootstrap stuff is like the node runs out of resources and it needs to become more. And then it scales, and then it uses the control data plane in the cloud to scale. If you haven't disabled instant metadata access through your workload, which is pretty hard to do actually, you have to really click. And it's not the instant metadata layer version 1 or 2 in AWS, and we're going to talk about why that is not the case. That's just a thing to protect you from CSRF. We're in the cluster now. CSRF or SSRF is not a thing anymore. We're in the cluster. So server-side request forgery, this is not it. We're in the cluster, we're able to query resources. So in this case, we're able to extract a certificate, everyone can see it, and a key, and a certificate to the API server. And this has to be because the PKI infrastructure needs to trust Google in order to create a node. So far, so good, right? And when that is bootstrapped and done, our cluster sort of takes over, and RCE will sort of be the cool kid on the block. So what if we try to use this bootstrap key in order to query our cluster? It's not working, right? So that is not working. It's not in the scope, right? So it's bad, sad. More often, this is really sad. This is what you look at, forbidden, unauthorized. It's sad. But we don't give up. So imagine if you could get a certificate request. And imagine if you could do something with that in order to get a valid certificate from your cluster. How does the cluster know that my certificate request is not valid? How does that work? How can Google create something for me with a certificate, obviously, and I'm not able to use it through my own cluster? That doesn't make sense. So why is it even there, right? Yeah, this is a little bit weird, but yeah. So if I'm able to do, I'm able to do this, and automatically certificate requests in my cluster from the node will be approved. At least it was that until 1.26, I think. So if you're running that version still, you're still vulnerable for this. There is some mitigations inside of this. So basically, I'm going to jump a little bit. We can create a valid certificate for a node inside of our cluster using OpenSSL, which will then give us the authority to impersonate a node, because the certificate authority in the cloud will not know what we're trying to scale up and down, because we got the keys, right? So with a little bit of shenanigans, we're able to create a certificate that is valid for a node that is not us, which will then give us access to list the cluster as the node. This will be in more detail in a Git repository at the end, so you can play around with this. This is a fun thing as well, like node escapes. That's really fun. So if you have a shell on a node, game over. And this is a shout out to Duffy Coley, who did this amazing one-liner where you sort of can create a privileged pod if you're that capable, and then, yeah, sort of do a reverse shell to the node, and then you sort of own the cluster. You own the node. And this is a new slide. Anyone in here uses this? It's sad. This is sad, because this is actually a thing now. This is actually vulnerable. I talked with some of you guys on this during the dinner, so I said, I'm going to add this. This is funny. So Carpenter, since no one has used it, but it's sad. It is something for AWS. Can we all agree upon that AWS, like cloud billing, anyone knows exactly how it works? Nope. We know that it's more cost, like every month, depending on how much we scale down and up, it always costs more, basically. So in comes Carpenter to solve the day. So Carpenter is basically a spot price scaler for your cluster. So it will actually have a look at what's the current prices of different instances in AWS, and it will scale you to the most efficient and cheap node, like instance that you can buy. So it's sort of, the idea of this is to keep costs down. I wonder how that works. Hence the headline. Are you sure you're just a carpenter? So we're inside a pod. And we all agreed that the pod is a part of a node. And inside this node lives Carpenter, trying to save you money, right? So now we're coming into a really cool thing. So we're trying to do a curl here to the instant metadata layer. And what happened? We don't get access, right? Because some clever dudes has disabled the instant metadata layer version 1. Which is like, yeah, we mitigated all the shenanigans in the world. But one thing we have to remember is that we're in the metadata control plane. We're not doing a server-side request forgery. So we can simply just do this. We can curl the metadata token, get the token that we need in order to do a query against the instant data layer version 2, which is mitigating CSRF, but not what we're doing. We're echoing that into token, and guess what? We can query the metadata layer again. Perfect. So that's not how you do it. That's not how you prevent control plane access to the cloud from within inside a cluster. That has to be done in the EC2 instance on a level where you sort of click down or disable it. This is just for web application stuff, mitigating server-side request forgery. The control data plane will always be valid and reachable if you not explicitly disable it in the cloud context. So yeah, what happens here? Yeah, we're querying the instant metadata layer from this amazing toolbox of Doom. And we see that we are a whoop, low-level users have no fun, basically. But then again, remember, Carpenter is running on this node. So if we do another query, look at the security credentials, Carpenter somehow, amazingly, appends the access right for the default EKS node group. I wonder what that can do. I think it could sort of spawn clusters and whatnot, right? So we query that one. We get back the keys, obviously. And then we just configure a profile locally. And when we do the STS get caller identity, we have assumed the role of the default EKS node group of EKS in AWS. And guess what? We can create a new kube control configuration locally and query kube control from our machine. We don't need the shell anymore because we are now the default node group in EKS. And then, yeah, we don't have to do any shenanigans anymore because we own the cluster through Carpenter, basically, because that sort of appends it by default. And it has to be that way because Carpenter needs to have access to scale up and down. But then again, if you breach a workload on the same node, we have a problem because that will be the same EC2 instance. So that's why you need to really ensure that your control data plane or the instant metadata layer is not reachable from your web applications or from your front end. That doesn't make any sense. Why is it even there? You don't even have to have it. But we don't know about it. That's why I'm here. We need to disable that because it's sad. How am I for time? Pretty good. Yeah. And the instant metadata layer is always a treasure trove of fun. How many in here works with EC2 instances? Or has been working with EC2 instances or computing instances? A few of you. Basically, it's a machine running in everything. Basically, that you run in the cluster is a machine somewhere. But EC2 instance is basically the glue in AWS. It's a lot of focus on AWS here. I'm sorry, but that's just how it goes. So in an instant metadata layer, there are user data sort of added or appended to the service you're running, and that will consist of a bunch of attributes. It could be like VPCs, security groups, credentials, manifests, bootstraps. It could be whatever. It could be a bunch of things just laying there in order to do instrumentation for the cluster. We don't really focus so much about it because it works. So hey, but the funny thing is with this is that if you do like the build pipeline, for example, you're having a cool infrastructure as code pipeline where you sort of deploy stuff, and that is done through Bash or YAML or Ansible or Terraform, whatever, like any infrastructure as code thing. That will more likely be appended to something called the user data attribute on the service instance that you're running it on. Maybe this is a bunch of gibberish, but I'm going to show you an example. So the instant metadata layer in the user data attribute is readable, right, for anyone that has access to that sort of specific service. So you could do this. You will get the bash script for this as well. So what this does is that it uses the AWS CLI, and it goes through all the EC2 instances, and it spits out whatever value is still present within the user data attribute. And you will find so many nice things in there. You can find this, like the admin Joe with the Sommar 2003 exclamation marks username and password, which is cool. But you can also find complete bootstrap manifest. If you're running COPS, for example, don't do it. But if you do it, then the entire bootstrap process of COPS will be here with all the hashes and keys that you need. A bunch of treasures lies in the user data attribute. So if you're doing pen testing, you should really look into this. And if you're doing development work, you should be sure to clean this out, because otherwise it could be very, very, very dangerous. So this is basically what it does. So it uses the AWS CLI with a profile auth breach, and it says EC2 describe instances, and then it just queries and then spits out all the values inside of the user data attribute, which you could use to potentially pivot. That's sort of the thing here, right? How am I doing for time? Pretty good, actually. This talk is basically an hour, but I'm still good for time. Holy. So time for a recap again. So yeah, we're back here at the treasure trove, right? So we were able to sort of use the mighty web application horse to sort of get through the cluster, right? And inside of the cluster, we found a bunch of tickets basically to cross the sea of unbreached clusters, basically. And we picked the nicest one because we like comfy seats. And then we're sort of able to get to the keys of the kingdom, which is pretty sad, right? So yeah, clouding is hard. Yeah, try to know what you're doing, basically. So the takeaways and conclusion for this talk is basically security is hard. It will always be hard, especially now because everything is changing all of the time. Like all the stacks and everything is constantly evolving. I am a firm believer on automation. I think that is the key in order to do something good, because there is so much noise. So I think automation and audit logging should be implemented, and that's where you should spend a lot of time. And you should ask yourself, is it reasonable that my server can install binaries and compile them? Is it reasonable that my server can connect to a server in Partille in Gothenburg and start to do a bunch of shenanigans? No, maybe not. Think about the big picture. Everything is nowadays connected in a cloud. Everything is a mesh, basically. You need to know exactly what your application is doing and what it's connecting to. Especially like modern day web applications, like holy, it's a mess. Like you have 1 or 2 cloud providers, you have a CDN, you have some asset repository, you have external third parties. Like it's hard to keep up, and don't trust the build platform, don't trust the frameworks. You have to know everything. You have to know what you're actually doing. So separation is key, basically. You have to know what you're doing. Zero trust, if you have it. And then some shameless plugging time. You should go here. You already know that since the intro. Go here. And if you have something cool to talk about, send your CFP. And this is, we made it to the end, guys. This is it. You have any questions? You can, feel free to reach out. This is me. And all the one-liners and more detail of what we talked about here is actually can be found in the cloud stuff repository. So go bananas. Any questions? Don't be shy. I saved 4 minutes for you guys. Yeah, go ahead, sir. Yeah, there is, but the thing is, I'm really expensive. No, but the thing is, like, if you like, there is a bunch of reconnaissance things that you could do. The thing is that it's time consuming to do it in a scale. So I have an automation platform that's really cool that could do this, but it costs a lot of money to run it hourly, and that's not because the automation is expensive, it's because I am. So black box testing is a dead thing, because it's like bug bounty stuff, it works. There is a bunch of recon tools out there, like recon everything is a good thing to look into. It's a repository where you can sort of learn how to do recon at scale. But for me as a penetration tester, or for a company buying a penetration tech, black box testing is just ridiculous, because you will find one vulnerability and that will be pivoted max. So I've done a bunch of black box testing in the day, and that's like you find one vulnerability and you stick to that one and try to sort of do maximum impact. So if you get like a huge scope, the only thing you will get from doing a black box on that scope is one entry vector, basically, because you will be lazy. Yeah, anyone else? Yes, sir, go ahead. Yep. Yep. Yep, it is. Yep. Yes. Well, I can, because it's mutable, it's only the image, right? So when it's in runtime, I can do anything that's on the image. Oh, exactly. So the thing is here that in order to sort of give you a longer answer is that you should, in your development pipeline, you should have an image that should be hardened. That could be done by ShaneGuard, for example, Wolfie, which is a really good project, open source, that has a secure context, not distroless container, but secure context to containers. So ShaneGuard and Wolfie, really good. But you should have multi-stage boots or multi-stage builds. So you should spawn the container with root, do all your shenanigans, drop the capabilities, and then production. That's what you should do. And then you could ask yourself, why do I need a shell? Because it's convenient and nice, yes, but then you can use a sidecar. Because you don't want attack surface on the pod. That's the sort of notion here. It's like a web application is a web application, not a fully fledged shell on the web. That is, custom code would always be vulnerable, so it's really unnecessary to give the antagonists tools, basically. Yeah, that's a thing, but I will exploit, like, that's a good question. So if firmware will die when I reboot it or restart it, yes, that's a good thing. But the thing is that your web application doesn't like to be restarted and not available, so why would you restart it regular basis? Then you have to scale it, and then it will be a part of a bigger workload. And if I'm just in it, it doesn't really matter. So the thing is that we have to have a layered approach. Like the images itself, I do believe that busybox, curl, vget, Alpine in general should be like remove all the binaries. Why do I have a compiler? Why do I have a package manager inside of an image running something that it's built? It doesn't make sense. Anyone else? I got 13 seconds. Come on. Nope. Yeah, come find me if you have any more questions. Thank you so much for having me.